performance out of early transistors was to run them close to their collector to emit a breakdown voltage. This made the TR1 very expensive to run, and it was far more popular for its novelty or status value than its actual performance, rather in the fashion of the first MP3 players. Still, aside from its indifferent performance, the TR1 was a very advanced product for its time, using printed circuit boards, and what were then considered micro-miniature components. Masaru Ibaka, co-founder of the Japanese firm Sony, was visiting the United States when Bell Labs announced the availability of manufacturing licenses, including detailed instructions on how to manufacture junction transistors. Ibaka obtained special permission from the Japanese Ministry of Finance to pay the $50,000 license fee, and in 1955 the company introduced their own 5-transistor code pocket radio, the TR-55, under the new brand name Sony. This product was soon followed by more ambitious designs, but it is generally regarded as marking the commencement of Sony's growth into a manufacturing superpower. The TR-55 was quite similar to the Regency TR-1 in many ways, being powered by the same sort of 22.5-volt battery, and was not much more practical. Note, according to the schematic, the TR-55 used a 6-volt supply. Very few were distributed outside Japan. It was not until 1957 that Sony produced their groundbreaking TR-63 shirt pocket radio, a much more advanced design that ran on a standard 9-volt battery and could compete favorably with vacuum tube portables. The TR-63 was also the first transistor radio to use all miniature components. The term pocket was a matter of some interpretation, as Sony allegedly had special shirts made with oversized pockets for their salesmen. Duration, 17 seconds. 0:17. 1955 Chrysler Philco all-transistor car radio breaking news radio broadcast announcement. In the 28th of April, 1955 edition of the Wall Street Journal, Chrysler and Philco announced that they had developed and produced the world's first all-transistor car radio. Chrysler made the all-transistor car radio, Mopar Model 914HR, available as an option in fall 1955 for its new line of 1956 Chrysler and Imperial cars, which hit the showroom floor on the 21st of October, 1955. The all-transistor car radio was a $150 option. The Sony TR-63, released in 1957, was the first mass-produced transistor radio, leading to the mass-market penetration of transistor radios. The TR-63 went on to sell 7 million units worldwide by the mid-1960s. With the visible success of the TR-63, Japanese competitors such as Toshiba and Sharp Corporation joined the market. Sony's success with transistor radios led to transistors replacing vacuum tubes as the dominant electronic technology in the late 1950s. Hobby use, edit. The first low-cost junction transistor available to the general public was the CK722, a PNP germanium small signal unit introduced by Raytheon in early 1953 for $7.60 each. In the 1950s and 1960s, hundreds of hobbyist electronics projects based around the CK722 transistor were published in popular books and magazines. Raytheon also participated in expanding the role of the CK722 as a hobbyist electronics device by publishing Transistor Applications and Transistor Applications Volume 2 during the mid-1950s. Transistor computers, edit. Main article, Transistor computer. The world's first transistor computer was built at the University of Manchester in November 1953. The computer was built by Richard Grimsdale, then a research student in the Department of Electrical Engineering and later a professor of electronic engineering at Sussex University. The machine used point-contact transistors, made in small quantities by STC and Mullard. These consisted of a single crystal of germanium with two fine wires, resembling the crystal and cat's whisker of the 1920s. These transistors had the useful property that a single transistor could possess two stable states. The development of the machine was severely hampered by the unreliability of the transistors. It consumed 150 watts. Metropolitan Vickers Limited rebuilt the full 200 transistor and 1300 diode design in 1956 using junction transistors for internal use. The IBM 7070, 1958, IBM 7090, 1959, and CDC 1604, 1960, were the first computers, as products for sale, based on transistors. MOSFET, MOS transistor, edit. Main article, MOSFET. In 1955, Carl Frosk and Lincoln Derrick accidentally grew a layer of silicon dioxide over the silicon wafer, for which they observed surface passivation effects. By 1957, Frosk and Derrick, using masking and predeposition, were able to manufacture silicon dioxide transistors and showed that silicon dioxide insulated, protected silicon wafers and prevented dopants from diffusing into the wafer. J.R. Legendre and W.G. Spitzer studied the mechanism of thermally grown oxides and fabricated a high-quality Psi-SiO2 stack in 1960. Following this research, Mohammed Attallah and Dewan Khan proposed a silicon MOS transistor in 1959 and successfully demonstrated a working MOS device with their Bell Labs team in 1960. Their team included E. E. Labate and E. I. Povolonis, who fabricated the device, M. O. Thurston, Ella D. Azaro, and J. R. Legendre, who developed the diffusion processes, and H. K. Gummel and R. Lindner, who characterized the device. With its high scalability, and much lower power consumption and higher density than bipolar junction transistors, the MOSFET made it possible to build high-density integrated circuits, ICs, allowing the integration of more than 10,000 transistors in a single IC. The first gallium arsenide Schottky gate field effect transistor, MESFET, was made by Carver Mead and reported in 1966. The first report of a floating gate MOSFET, FMOS, was made by Dewan Khan and Simon SZE in 1967. The MOSFET has since become the most widely manufactured device in history. As of 2018, an estimated total of 13 sextillion MOS transistors have been manufactured. PMOS and MOS, edit. There were originally two types of MOSFET logic, PMOS, P-type MOS, and MOS, N-type MOS. Both types were developed by Frosk and Derrick in 1957 at Bell Labs. PMOS, edit. Main article, PMOS. A new type of MOSFET logic, PMOS, complementary MOS, was invented by Chitang Sar and Frank von Lass at Fairchild Semiconductor, and in February 1963 they published the invention in a research paper. Self-aligned gate, edit. The self-aligned gate, silicon gate, MOSFET transistor was invented by Robert Kewin, Donald Klein and John Saras at Bell Labs in 1967. Fairchild Semiconductor researchers Federico Fagin and Tom Klein later used self-aligned gate MOSFETs to develop the first silicon gate MOS integrated circuit. MOSFET commercialization, edit. Main article, MOSFET applications. The MOSFET, also known as the MOS transistor, was the first truly compact transistor that could be miniaturized and mass-produced for a wide range of uses. It revolutionized the wider electronics industry, including power electronics, consumer electronics, control systems, and computers. The MOSFET has since become the most common type of transistor in the world, with uses including computers, electronics, and communications technology, such as smartphones. The MOS transistor has been described as the workhorse of the electronics industry due to being the building block of every microprocessor, memory chip and telecommunication circuit in use. Billions of MOS transistors are manufactured every day, as of 2013. Integrated circuits, edit. General Microelectronics introduced the first commercial MOS integrated circuits in 1964, consisting of 120 p-channel transistors. It was a 20-bit shift register, developed by Robert Norman and Frank von Lass. In 1967, Bell Labs researchers Robert Kewin, Donald Klein and John Saras developed the self-aligned gate, silicon gate, MOS transistor, which Fairchild semiconductor researchers Federico Fagin and Tom Klein used to develop the first silicon gate MOS IC. By 1972, MOS LSI, large-scale integration, circuits were commercialized for numerous applications, including automobiles, trucks, home appliances, business machines, electronic musical instruments, computer peripherals, cash registers, calculators, data transmission and telecommunication equipment. Semiconductor memory, edit. Further information, computer memory, memory cell, computing, and semiconductor memory. The first modern memory cells were introduced in 1965, when John Schmidt designed the first 64-bit MOS SRAM, static RAM. In 1967, Robert H. Dennard of IBM filed a patent for a single transistor DRAM, dynamic RAM, memory cell, using a MOSFET. The earliest practical application of floating gate MOSFET, FMOS, was floating gate memory cells, which De Won Kang and Simon SZE proposed could be used to produce reprogrammable ROM, read-only memory. Floating gate memory cells later became the basis for non-volatile memory, NVM, technologies including EPROM, erasable programmable ROM, EPROM, electrically erasable programmable ROM, and flash memory. Microprocessors, edit. The MOSFET is the basis of every microprocessor. The earliest microprocessors were all MOS microprocessors, built with MOS LSI circuits. The first multi-chip microprocessors, the four-phase systems L1 in 1969 and the Garrett I Research MP944 in 1970, were developed with multiple MOS LSI chips. The first commercial single-chip microprocessor, the Intel 4004, was developed by Federico Fagin, using his silicon gate MOS IC technology, with Intel engineers Marcian Horth and Stan Mazer, and Bizicom engineer Masatoshi Shima. With the arrival of CMOS microprocessors in 1975, the term MOS microprocessors began to refer to chips fabricated entirely from CMOS logic or fabricated entirely from MOS logic, contrasted with CMOS microprocessors and bipolar bit slice processors. Pocket calculators, edit. One of the earliest influential consumer electronic products enabled by MOS transistors was the electronic pocket calculator. In 1965, the Victor 3900 desktop calculator was the first MOS LSI calculator, with 29 MOS LSI chips. In 1967 the Texas Instruments Caltech was the first prototype electronic handheld calculator, with 3 MOS LSI chips, and it was later released as the Canon Poctronic in 1970. The Sharp QT8D desktop calculator was the first mass-produced LSI MOS calculator in 1969, and the Sharp L8, which used 4 MOS LSI chips, was the first commercial electronic handheld calculator in 1970. The first true electronic pocket calculator was the Bizicom LA120, a handy LA, which used a single MOS LSI calculator on a chip from Mostec, and was released in 1971. Personal computers, edit. In the 1970s, the MOS microprocessor was the basis for home computers, microcomputers, micros, and personal computers, PCs. This led to the start of what is known as the personal computer revolution or microcomputer revolution. Power electronics, edit. The power MOSFET is the most widely used power device in the world. Advantages over bipolar junction transistors in power electronics include MOSFETs not requiring a continuous flow of drive current to remain in the on state, offering higher switching speeds, lower switching power losses, lower on resistances, and reduced susceptibility to thermal runaway. The power MOSFET had an impact on power supplies, enabling higher operating frequencies, size and weight reduction, and increased volume production. The power MOSFET, which is commonly used in power electronics, was developed in the early 1970s. The power MOSFET enables low gate drive power, fast switching speed, and advanced paralleling capability. Sustainable transistors, edit. In late April 2023, researchers at Linköping University and KTH Royal Institute of Technology successfully developed the world's first wooden transistor, potentially paving the way for more sustainable electronics and even the control of electronic plants, according to an article on Hackster.io. The team created a functional transistor to switch electronic signals using cellulose-based electrolyte and lignin-derived organic semiconductors. This breakthrough could lead to further research in creating environmentally friendly electronic devices and exploring the possibility of integrating electronics into living plants for monitoring and control purposes. Patents, edit. 1 US 1745175 Julius Edgar Lilienfeld, method and apparatus for controlling electric current, first filed in Canada on the 22nd of October, 1925, describing a field effect transistor. 2 US 1900018 Julius Edgar Lilienfeld, device for controlling electric current, filed on the 28th of March, 1928. A thin film field effect transistor. 3GB 439,457 Oscar Hale, improvements in or relating to electrical amplifiers and other control arrangements and devices, first filed in Germany on the 2nd of March, 1934. 4 US 2524035 John Bardeen et al. 3-electrode circuit element utilizing semiconductive materials, oldest priority the 26th of February, 1948. 5 US 2569347 William Shockley, circuit element utilizing semiconductive material, oldest priority the 26th of June, 1948. 6 US 3206670 Mohammed Attallah, semiconductor devices having dielectric coatings, filed in the 3rd of August, 1960, describing a MOSFET. 7 US 3102230 Daewon Kang, electric field controlled semiconductor device, filed in the 3rd of August, 1960, describing a MOSFET. References, edit.